we are going to make a comparison of electrical energy source from the perspective of production capacity. Here is pretty well topics. First, a little introduction, some definitions. Then we're going to compare Brazil and US, especially the capacity factor and firm energy. Also discuss the complementarities that we can use, US or Brazil. Some conclusions and goals. And after, something about institution engagement between our institutions. Okay. Production capacity is always growing. Our population is growing, industry, especially in the developing world. We need to improve our capacity of production, but also we have to face some concerns, especially these three. Improve the reliability of the grid, reducing the generation cost, and also improve the participation of clean energy. Okay. Both countries, US and Brazil, has a lot of difference in the way that they produce energy. Ours is mostly renewable, but we have some problems with reliability sometimes because we use too much hydro. But also we can, we have so much potential, and in the future it is going to be all sustainable. And it's really important to improve the reliability of these systems. We don't have much storage and concerns about wind and solar yet. So the capacity factor and the firm energy are two parameters that are really important to analyze. I need to show them.
So after that introduction, going straight to some definitions. So the first thing, capacity factor. I'm sure many of you know it, but as the word equation shows, so all it is simply the amount of energy that's actually produced in a given time period by a specified source, divided by how much you could produce the maximum amount if you had been producing at full capacity that entire time. So obviously, just based on that, it's a ratio, from 0 to 100%. And so this capacity factor can be, it's affected by a wide variety of things, some of which we as engineers have control over, and some which we don't. So for instance, one of these things is the design and the operation of the plant. And so this is one of the factors that we as engineers can control to a large extent. So for instance, just to illustrate that, a thermal plant in the US is designed to have a very high capacity factor because it operates most of the time, so it produces a large amount of energy consistently throughout the year. In contrast, though, a very similar thermal plant in Brazil is designed to have a much lower capacity factor because you know that it's designed to be a backup plant. So a second thing that we have a little bit of control over is the fuel type. So if you're looking at thermal, say you have a coal-based thermal plant, assuming you are willing and able to keep paying for coal and you can keep importing it, you can get a capacity factor of almost 100% because the fuel supply is, you can regulate that. Wind, on the other hand, is not something that we have control over. So for wind, you are dependent on when the wind happens, and so the capacity factor again is a lot lower. And so that transitions well into the aspects of capacity factor that engineers really have no control over. So things like seasonal variations. So even within one wind farm in Brazil, say, the summer winds versus the winter winds are very different, and so you are likely to have a much higher capacity factor in the winter when there are more winds. Just taking a look now. So obviously all of these things relate to the reliability of the power sources. So the ones that we have no control over are especially important for us. So things like the kind of fuel you choose and the seasonal variability as well. So then the second definition that we looked at is firm energy. So what this simply is the amount of electricity, in this case specifically, that can be guaranteed to be supplied at any given time. So of course ignoring unforeseen big events like floods or hurricanes or things like that. So we've heard a lot throughout the course about the contracts that suppliers in Brazil sign up for. So that is in essence firm energy or guaranteed energy. So the amount of energy that is written in that contract, you need to be able to produce that independent of where you need to go to get that energy in the end. So firm energy in the US, for instance, typically operates, the plants operate at full power most of the time. So again, nuclear and thermal in the US, they're considered firm energy. You can rely on them
important to say that we couldn't find a value for firm energy in Brazil because it's not yet integrated to our Brazilian intake system. Fossil fuels here, we consider just coal in order to compare both countries. Biomass and nuclear. So here we can see that the most important difference between countries are related to hydropower, coal, and nuclear power. Because hydropower, we have, although the capacity factor is almost the same, our firm energy here in Brazil is much bigger because our system relies on the source of energy. Related to coal, the capacity factor of the US has, because the firm energy is much bigger. But it's important to say again, as Kim said before, that our capacity factor is smaller, but not because we don't have efficiency, but because we don't want to use thermal power plants to generate energy in order to avoid greenhouse gas emissions and high costs of energy. And related to nuclear power, the capacity factor is almost the same, but in the US they have a lot of nuclear plants, so that's why the firm energy is much bigger than ours.
So, considering this, how we can mix those sources in order to achieve reliability, sustainability, and economic viability. For instance, we'll take the Brazilian case first, where we have mainly hydro generation, which has some advantage, but we have some problem with reliability. As we have seen, we rely on St. Peter, and since most of the new hydro plants are on a river, we have a decrease on the relative storage capacity of our reservoirs. That makes us even more dependent on St. Peter, and sometimes it doesn't help us. And what happens is that the cost of the energy gets really high, which is not good. So how can Brazil increase its capacity considering this problem? As we have seen, Brazil has a really good wind potential, both on and offshore, but it also has some reliability problems. So instead of depending on St. Peter, we will depend on with the wind god. But as we have seen many times, wind and hydro complement themselves. So where the hydro, during the dry periods, we have good wind, so we could increase the reliability, not spending the water, so we could store more water and use the wind generation. But still we need these hydro plants because we have a huge potential and we have already a great capacity installed in hydro generation. And also we have biomass mainly from sugarcane that also has its great potential during the dry period. So we can complement, they can complement themselves in order to achieve a greater reliability. And here's a map of Brazil and its integrated system. And the goal here is to take advantage of each region greatest potential in order to achieve reliability, sustainability, and economic viability. So here's a quote from IE Eólica that says that hydroelectricity would be our anchor, our main source. And the other sources would complement the hydro when it's needed. So for an example, here in the northeast, I believe we have seen graphics like this many times, the hydro is better on the summer and winds better on the winter, which is the dry period. So we can mix those sources here on the south too. So we use whichever is best at the moment. And on the southeast, we have biomass mainly for sugarcane that also has this behavior.
Yeah, so we're going to talk about complementarities in the U.S., and really most of them are, coming from integrating wind into the energy matrix in the U.S. The reason why that's the case, because the U.S. is, 2/3 dependent on thermal, right? Most of the complementarity that you're going to find is more based in the market seasonalities, rather than resource seasonalities like in the wind and the water resources, right? What's not presented up here is the fact that in natural gas, you're going to see, like in the market price of natural gas, you're going to see winter peaks, right? So December, February, January, things are going to be very expensive, but things start to really come down in the month of April, right? Just before the winter peaks, that coal takes over, and because the U.S. is mostly dependent on coal, because the U.S. is mostly dependent on coal, you're going to need something like natural gas to really level out. Taking a step back, you're going to need some form of energy to level out the cost over the course of the year, right? And wind power is really presenting itself as that source of energy to do that. The total potential for wind power in the U.S. is 10 terawatts, 4 terawatts offshore, 6 terawatts onshore. Keep in mind that the offshore power is roughly 4 times as expensive as the inland wind source, wind power potential. So, yeah, the way that we use wind to complement a really volatile market is to rely on the fact that there aren't a ton of seasonal variations in the resource-dependent energy sources in the U.S. That's hydro, that's wind. The capacity factor changes, usually shifts from 25 to 35%. 25 to 35% in wind over the course of a year, and the times that energy shifts actually work well with the big resource drives over the course of the year in the U.S. That's the winter, the summer, air conditioning, and heating. So we could use wind power because it has really no variable cost outside of maintenance to bring down the cost of energy in the U.S. and really reduce our dependence on domestic and foreign fossil fuel.
So, after this 2-week course, collaborative course, we conclude some things. First of all, the energy matrices are pretty different, talking about the US and Brazil. But this is not a conclusion at all, but most is a fact. Why? Because energy matrices, they're gonna say what kind of ensure reliability and what kind of complementarity we have. So, why? Brazil and US, they have different geographic characteristics. So, like we saw here, Brazil US can produce, use the corn, talking about biomass, and Brazil doesn't use nuclear power plants like US. So, talking about this, we thought we conclude that the most important reason for this course and the next few course and engagements is talk about exchange, the best knowledge of each country. So we know that the US, we saw in the lecture of Professor Aziz, that the US, they have more than 100 nuclear power plants, while Brazil, we are building our third. And we saw in the Electrobras, they intend to build 6 more power plants. So one thing that we really consider that is pretty important is exchange ideas. What the US can bring to Brazil and what Brazil can bring to the US. Probably one thing that's pretty important for us, talking about power plants, is the safety of the power plants. Why? We just have 3, so we are not used to many different situations, talking about safety stuff. While in the US, we can bring to the US the technology about biomass that we saw like 2 days ago, how the big amount of biomass we can produce. How we have different ways to produce energy, we should think about which kind of ideas talking about sustainability we can bring to the US and how they can improve our ensure reliability. So we have this. safer nuclear technologies and biomass technologies, so we can change renewable source and reliability. And what are the other kind of engagements we can do? We think that this kind of course is pretty important, and also the exchange situations like Professor Mieswa has been in the US to talk about collaboration in research, because we don't think that there are many centers in Brazil and even in the US that put people together to collaborate and develop new technologies like we saw in IBM, and also Chad could show us. So we think that we believe that this kind of engagement in the future should be like one of the best things that we can provide for our countries. So in name of our group, we'd like to thank everybody, all the professors, all the people from Protectus, Gil, Patrick, everybody who joined us, and thanks so much for this course.
So I understand how you could bring safety knowledge from one place to another based on experience, but how would you take biomass experience that requires climatic conditions or...
Yeah, what happened is the second generation of biomass is not just the sugar cane use the bags. So the heat capacity is different. So the second and the third generation, if they are developed in Brazil, like you saw, there is a center and all the foreigners are pretty welcome. So this is a way to improve their biomass use in the US. But you have to wait a little bit.
And there are also like motions to bring biomass to coal-fired plants. There's a big movement to retrofit coal-fired plants to burn biomass, and actually the first completely retrofitted plant is actually up and running in New Hampshire. It's the Shopping biomass plant. It was up and running in 2009, and it cost $70 million to retrofit, which is much less than the cost of completely reinstalling a new coal-fired plant. So they're also, you know, comparisons to the market and like relationships that can be established there.
And how do you think the firm energy factor and the capacity factor can influence the planning on the expansion of the system?
Which system?
Of the system, of the generation system. How to take into account the capacity factor and the firm energy concept to, as an input, the planning of the expansion of the nuclear generation. Because Brazil has to increase the generation in the next few years. So how important it is to consider this, because as you showed us, different types of energy production have different firm energies and capacity factors.
So one thing is the complementarities, because the capacity factor of wind, solar will always be limited. The other thing is the storage. If you have good storage, you produce wind when it's windy, and you storage when it's not windy. All this stuff is related to capacity factor. But also when you design a new power plant, you're already thinking about the capacity factor. If you're going to build a really big hydro, you're going to make it sure that it's working top capacity factor, as a type 2. Because even the machines have to work, I mean, they're designed to be used in certain capacity factor. Otherwise, they don't have much efficiency. So I think it's mostly complementaries and storage.
Yeah, I must think the system as a whole. So if you are planning a power plant with low capacity factor like Belo Monte, then you must know, okay, this won't have a high capacity factor, what I'm doing to ensure reliability, how can I complement this. So planning is really important in order to take everything in account. Then, okay, I have low capacity factor power plants, but I also have these and these to make the whole system reliable.
And in the US, there's a concept of energy floors supplied by different sources of energy. Like, for example, nuclear power can't really be shut off and you can't take it off the grid. So 20%, that 20% of nuclear energy that's supplied to the US will just always be supplied. If you take that to the capacity factor of wind energy, right, when a windmill is running, you can't really, like, unless you want to disconnect the bill from the grid, that energy is going to be entering your matrix, right, at that time, and then it's not going to be for the other 75% of the time. So it's really, the way that you could be planning is going to be from the ground up in the US case, right, knowing when you're going to have what type of energy, like at bare minimum, and how much variation you're going to be able to field, you're going to be able to risk as you incorporate more renewable sources of energy that aren't, are more intermittent.
Okay, now, so we are comparing different sources, but based on the research that you did, so how, what we conclude would be the best energy source for our country?
There's not the right answer. It depends on the country, what resources have. And for Brazil, we had that quote from the Eólica that says that for us, the best thing is to have hydro as our main source, and the other renewables will there to ensure more reliability and more flexibility. So a huge hydropower plant park with wind, biomass, solar, nuclear, and other sources to complement this.
I think it really depends on your definition of best, obviously. Do you want energy right now
Yes,
for the
yes,
short
because
term
as
or
an
the long
engineer,
term?
like an engineer, you need to supply energy for the country, so that's the best.
Depends how much money you have. You can energy in the grid, like the full time, the power plants running on biomass, coal, depends the combination of sustainability and money and social effects. So you can think that coal is the past and wind is the future, but you know, we never know.
Actually, the answer is depends on the resource that you have. So that's the best. So
Yeah.
you only can use what you have, otherwise you cannot use. So that's important you think about as an engineer. So sometimes a lot of people talk about some kind of energy source that you can use, like, so the solar energy can supply all the energy in the world. So if you take the Sahara Desert, so there is enough energy to supply everyone, but is it feasible or not, and how much it will cost, the environment impacts. So that's the thing we need to think about.
So
There is no best energy source. There is the one that you have. So as an engineer, you can work with that.
yeah, I think we should also think about the future. Like in the US, they have reliability of their system now because they use coal and nuclear, but the resources are not going to last forever. So
Yes.
like in 50 years, they have to think about a solution, and it's probably renewable sources and complementary factors.
Yeah. Okay.
Thinking about renewables as a way to work better for the society, but what happens if the climate change? The place that have rain, maybe not going to blow anymore.
The climate is changing. We just know if we are responsible for that. Like many points of view we have, but in the past people used to think that probably oil and gas will be provided forever, and now we know that it won't happen. And we are thinking about renewable source. If a climate change, probably we're gonna stay in the same situation that we are right now. We have to think about the future, and looks all it's happening right now. And another, we could say that we are in a kind of revolution, because the things are changing quickly, like we saw in Brazil, exponential, increase of wind, and like 5 years ago nobody would think about that. So we have, first we should face the situation, and now we can, and so we can think about something. Just think about, oh, what we're gonna do if something happens. Is, you know, it's like you are not in the situation to face properly.
Yeah, that's why when I said that 5% risk, we can live this.
Okay, thank you.